Hi everybody, welcome to this app challenge. In the last tutorial we were working on a database and we were looking at the idea of ACID properties of a well-designed and trustworthy database. Our database was based on a bank app and we used some data definition language, which is a subset of SQL, to quickly create 3 tables. Here they are. And we used some data manipulation language, which is another subset of SQL, to insert data into our database tables. Okay, so at the moment we've got accounts, we've got customers, and well, we don't have any transactions yet, but hopefully we will by the end of this tutorial. Notice that you can only have an account if you are a customer. Okay, so these customer IDs, which are foreign keys in the accounts table, have to have a related primary key value in the primary key table. And there they are. Okay, so what we did to enforce that, to help us keep a consistent and valid database, we created a constraint, sorry. Okay. Now, I suggested to you in the last tutorial that we would have to do the same in the transactions table, because this from account num and this to account num field are foreign keys in the transactions table, and we should be able to find the primary key field in the accounts table. Okay, and that is demonstrated in these schemas. Okay. We can see in the transactions table that these 2 fields are foreign keys, and the relationship takes us to the primary key field of the accounts table. Okay. Where am I going? Okay. So I'm going to show you now the constraints that I put into the transactions table, which was part of your challenge in the first tutorial. Did you manage to figure it out? This is the solution. I had to create 2 constraints, and they connect the foreign key field in the accounts table to the primary key field, in the transactions table, to the primary key field in the accounts table. And these are the constraints that we're going to work with. Okay? Okay, so now let's move on to getting started with the app challenge. You were tasked with going to your virtual server's root folder. That's what htdocs is. This is where all our server files are going to be stored for our local host server. Oh, notice one thing. My database is also stored on localhost. Okay, that's kind of important to realize. This is a localhost stored database. All of these files are also stored in localhost. We created a subfolder called bank app, and we've got these 3 files. And this is our bank app file. To access this file, we're going to have to visit localhost in our browser and find that bank app folder. There it is. And then we can call or request bankapp.php. Yay! Okay. So this is what bankapp.php looks like. Let's go and take a look at it in Sublime Text. Here it is. And as you can see, there is basically a form with 3 inputs. Input, input, input. And there they are. Input, input, input. Okay? Now, it also has a button. And when we click that button, we're going to call another file called process.php. We'll take a look at that in a moment. And what we're going to do, we're going to post the input data, which is going to be stored in these name properties of the input tags, okay? So if I type from account 0000000, when I click transfer, that value is going to be stored in a variable called from. And we're going to post it to process.php, okay? The to account is going to be stored in a variable called to, and the amount that we enter is going to be stored in a variable called an amount. These are the These are the variables that are going to be posted to process.php. So let's go and look at process.php. When it loads, it connects to the database. That's what this is doing. We're including this file. This is connecting to our BankApp database in our local host. Okay, so connect to the database and then just check if anything was posted. If it was posted, that's the data that was posted. That's that from. That's that thing there. The data 0000000. That was posted. So we're going to store it in a PHP variable. Do the same with to and do the same with amount. So we've grabbed the data that was posted into our local PHP variables, and now we can start processing them. Oh, we're going to begin a transaction. Do you remember in the previous tutorial we talked about transaction control language? So transaction control language, which is a subset of SQL, would look like that. Okay, but we're not going to use the transaction control language. We're going to use the PHP version of transaction control language. So we're going to start a transaction. Just going to get rid of that. That was just a comment, by the way. And the transaction, first of all, we're going to try to update the from account. We're going to update the balance of the from account by deducting the amount. Okay, and we're going to run that query. If something happened, that's really what that means. If something happened, it means we were successful. There was no error, and the database was updated after we ran the query. So that means that was successful. Yes. If that's true, we can go on and attempt to update the to accounts balance by adding the amount. We'll try and run that. That should be okay. And then we're going to commit because there were no errors. Everything was fine. That is PHP's version of transaction control language's commit keyword. Okay. Now then, if nothing happened after we ran the first query, it means maybe there was an error or maybe there was a constraint which stopped something from happening, stopped this from happening. So if the connected affected rows doesn't equal 1, which means it's probably equal to 0, then we're going to roll back. We're going to look at any potential changes or errors that were made, and we're just going to put the database back into its previous state before we tried to commit anything. That's what that's doing. And in transaction control language, we would just be using the keyword rollback. But this is PHP's version of the rollback idea, okay? So, if what I did with this code was I created a PHP variable called success and I gave it a starter value of false. After committing, I gave it a I updated the value to be true, and then I tried to figure out if success is true, then I'm going to set the status to be success. Otherwise, I'm going to set the status to be failed. And I'm going to send that status back to bank.php. This line of code here sends us back to this file. So this file reloads. We're sending it a variable called status. There it is. That's the status variable, which is storing some data. It's either success or failed. Okay. And what we're going to do is grab that message into another PHP variable and echo it, which means output it into an H1 tag under the form. That's how that works. Okay, I'm not going to keep explaining that too much, but see if you can figure out what's going on there. Okay. Okay, let's start the challenge. Here we go. What I'm going to do is, let's just see if this does work. I'm going to put in a valid to account, and and I'm going to try and transfer 500. Hopefully this is going to fail. Yes, because the from account wasn't valid. Let's just go to localhost for a minute. I want to go to accounts. Let's transfer $250 from account 00000 to 0000001. Okay, so from account 0000000 to account 0000001, we're going to transfer $250. Yes, it was successful. Let's see if the database was updated. Yes. Okay, so currently, customer 27 doesn't have any money at the moment, and customer 28 has $350. Let's see the transaction history. No, there isn't any transaction history. Okay, so that's part of the app challenge, guys. Can you, when we successfully commit a financial transaction, can you figure out how to update the transaction table, which needs these 4 pieces of information to be updated? Notice the primary key is an auto-incrementing key, so it will take care of itself. You need to take care of this data here, okay? Now the second challenge is, let's go back to accounts. This guy doesn't have any money anymore, but I'm going to do this. Oops, let's go back here. The guy who doesn't have any money, who's that guy, is going to try and send some money to that guy. Going to try and send $100. Whoa! Success! What? Oh no! We've just allowed something to happen that shouldn't be allowed to happen. The consistency, the validity, if you like, of our database is not very good. It's not very secure. Our database, if we think about the ACID property, C, consistency, it's inconsistent. It's allowing something invalid to happen. So the app challenge, can you stop a transfer when the customer doesn't have enough money to make that transfer? That's challenge number 1. And challenge number 2, after a successful transfer is completed, can you please record that transaction in the transactions table?